Hello all.
Hello.
Thank you very much for explaining definitely my microphone's working, which is good. So hopefully there's my my slides. I'm going to be talking today about building a real-time serverless application in Blazor using AWS, and really this is a sort of an ongoing journey for me. I started at the start of the year. I took an application that I was building previously in just as an ASP.NET website, and started to look into, well, how could I make it into a Blazor app, because I wanted to explore Blazor a little bit more. And over sort of I've done this talk about 4 or 5 times, and every time I sort of add a little bit extra to the application, or add a new feature, or clean up some of the code. And really, the talk's about explaining a little bit about a way that I like to do real time at the moment using a service from AWS called Web App Gateway and their WebSocket support. And then also how I've used that to combine with Blazor to sort of build a client application, which sort of uses that in the background. Now, my name is Martin Beeby. I've spoken at these meetups before. Some of you will hopefully know me. I'm at the Beebs on Twitter. Please do follow along on my Twitter. If you are brand new to AWS, but you're interested in AWS at all, or maybe experimenting with it, then do tweet me at the Beebs, and I will send you a $50 voucher for AWS, which you can just add to your account, and so you can experiment a little bit more outside of the free tier that is already there with AWS. And you can use it, I believe, on any account. So if you've already got an AWS account with us, then you'll be able to apply that voucher to your account and have a $50 discount. This is one of the most important slides, which I've been doing. I think the last time I was at this event, I was doing this inception slide. This is my slide, which explains who I am. And I'm somewhere in the region of 45 to 50 layers deep of pictures of me standing in front of a slide, 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 in front of a slide. I've got many of them on my website at thebeebs.net /inception slide, although it's a little bit out of date at the moment. And hopefully, if anyone has a camera and is at home or wants to take a picture, then this would really help me out, because there would be another link in my chain of inception slide. So this is, I don't know, I think about 40. I don't think it's 50 yet. I think it's like 48, 49. So hopefully someone screenshotted that, and then that will be the next link in my inception slide. And the hope is one day I'll reach 100, and that will be like the dream of this world. So we're going to be talking about building a real-time application. I'm going to touch a little bit on SignalR, because that's the way that I originally built with this application, and it helps to contrast the differences between the approach that I'm taking now and the approach I was taking before with SignalR. And most of the approach that I'm taking is just changing the way I think about the application and going and using serverless. So the advantage of using serverless in a system like this is that when the resources aren't being used, but when people aren't using the application, I'm not really paying anything for it. The concept being that with serverless, you're paying basically for usage. So as someone uses my web application, my Blazor application, and makes calls to various services, I only pay per call. And depending on the application, that can work out a lot cheaper than if you had to pay for a virtual machine, or even an app or a PaaS service or a subscription service where you're ultimately paying a certain amount every month. With most serverless products at AWS, you're generally paying per use. So with Lambda, which is one of the things I'll be using, you basically pay per invocation. So every time that Lambda function is run, you pay for that. And so it means that when this application isn't being actively used, I don't pay anything, and I'm only actually paying for it when it's actually used. And even when I'm paying for it, it ends up being quite inexpensive, just because of the way I've architected it. Then we'll lastly look at Blazor, and I'll show you how I integrated these WebSockets with Blazor. And I went on a little bit of a journey with Blazor as well, where I was learning different things about it and stuff. And hopefully some of that will be interesting to people which are brand new to Blazor. So when I say real time, what do I mean? Well, I mean anything inside of an application which is giving you like live feedback. So, you know, the WhatsApp message, when you're reading a WhatsApp message and it says that something's just been read, and you get a notification that someone's read it. Those little indicators that things are happening in the outside world, that's real time effectively. So The canonical example is chat applications where you're sending messages and receiving messages. You want that to happen in real time. And so you're developing systems to be able to do that. And traditionally, to build highly scalable real-time applications, you needed a lot of infrastructure. You needed a lot of servers. You needed probably a lot of maybe Redis backplanes and all sorts of things to support that application. And one of the things that I'm going to be looking at is the concept of doing that without requiring all of that infrastructure and all of that expenditure. An example might be on a hotel booking website, for example. Now, generally, when you're on a hotel booking site and you're booking a hotel, sometimes you'll see this just booked in London, 52 properties like the Doubletree Hilton. Now, the reality is they probably didn't implement this with WebSockets, and it's probably not real time. It's just a timer in JavaScript. But the idea or the concept is that it probably should have been done in a WebSocket, that when someone else is doing something on the website, it's alerting you to let you know that something's happened. So here it's saying just booked in London, these sorts of properties. It's trying to encourage you to then go and book the hotel as well, because you're thinking, oh my gosh, it's going to run out or whatnot. We use an internal AWS for our document management. We use a thing called Quip. I think it's Salesforce, which actually developed Quip. And it's a bit like Google Docs or any of those services. And you basically produce your documents. And then one of the really nice things I think is about that service is about Quip is that they show you who's viewing that document as you've sent it out. So I find it really interesting to email out and different times of the day and then look who's actually viewing it and who's actually reading my emails and who's not necessarily reading my emails to find out about my latest budgets and things. But it's just adding those sorts of real-time things like who's viewing a document, who's typing, who's working on the document. I think those things really help create a sense of interaction with a website and with an application. And it's starting to become, expected as well that you should have that level of interaction. I'm developing or working on a lot of real-time video solutions at the moment because of lockdown. We're doing lots of video stuff. And we have a video service called IVS, or Interactive Video Service, AWS IVS. It's actually developed from Amazon. AWS, if you don't know, they own Twitch. And Twitch, we sort of white labeled Twitch's technology so that you can integrate that sort of Twitch experience, but without any of the Twitch paraphernalia, into your own websites. And all of that's real-time video. So the interactions, like you basically can set markers and make API calls to trigger events. And it's this combination of video and WebSockets working in collaboration so that you can start creating these interactive experiences. So you can show when someone pushes a button in your studio, you can show a poll in the video on the video as an overlay, or you can open a website, or you can open. And we're using this IVS service at the moment. We have our big online conference coming up in December, and we're using IVS to do all of our workshops. And the idea being, as our workshops being talked through over video, the presenter can bring things up like GitHub repos and so that there's an interactive two-way experience with someone who's watching the video and also the person which is delivering the presentation. So there's lots of different like collaboration, interactivity. This is what real-time applications are all about. And one of the most annoying, I think, UI things of real-time feedback is this concept of someone is typing. I don't know if you've ever sat watching someone is typing on Skype or in WhatsApps, and then they stop typing, and then they start typing, and it's like this constant, are they going to say something? Are they not going to say something? It's one of the most annoying pieces of UI feedback ever to have existed. But it's using WebSocket in the background. This thing's probably using WebSockets to achieve that. And when I talk about WebSockets, well, what do I mean? It's basically if you're not familiar with the concept of WebSockets, and why should you be? It's the concept being as a WebSocket is effectively a communication channel between an application and a server, but it works in a duplex way, in that you can send stuff to a server and the server can also send stuff to you. And if you think about the RESTful way that the internet works, or the websites work, it used to be the case that just the browser could make a request of the server and some information would get sent back. But it wasn't really possible for servers to send information to apps. Now there's lots of ways for servers to actually send information to apps. And so the most common way that still is the way that most people work and real-time stuff happens is WebSockets, even if you don't necessarily know that WebSockets are the thing that's being used. So I know a lot of people which use GraphQL, for example, and they'll use the real-time capabilities of GraphQL. If you've not used GraphQL, it's kind of a bit like a NoSQL database, but it's also got this really cool real-time protocol where you can listen to data in the database, and when that data changes, you can react in your application. Now, it's really clever how it works, but fundamentally, it all just works over WebSockets. Now, WebSockets are basically this agreed protocol. There's more than one way to do real time, but WebSockets is the most commonly used now. And the way that it works is that the browser will send a request over to a server and ask the server if it's capable of doing WebSockets. Of course, it's 2020. Most servers can do WebSockets, but some can't. So older versions of IIS, older versions of web servers might not have the capability. And it does require both the application and the server to both have WebSockets capability. And it might be the case if you have a very old server, or perhaps you're using a very unusual client, that you might not have support. But you'll find that most SDKs on most client devices, whether they be watches or whether they be phones or whether they be browsers, now have support for WebSockets. And once that's happened, once you do this thing called a negotiation, basically it creates this connection between the two systems. And this connection is kept alive, and messages can be passed back and forth. The messages which get passed back and forth, we call them frames. But the concept is that effectively there is like a pipe between the two systems. And of course, this pipe has to actually manifest it somehow in the real world of websites, and that can be complicated by things like load balancers. Like, how do we actually genuinely create a pipe between this application and my server if the server, which is actually behind things, is being load balanced or being changed? And so there is some complication when you're doing WebSockets around that sort of thing. And that is fundamentally one of the challenges about why it's so difficult to scale WebSocket solutions. It's very easy to write demos in something like SignalR and get it working, but actually then to scale that to thousands of users or hundreds of thousands of users can be challenging, and it generally requires an awful lot of infrastructure. So when I first built my very first, well, it's not my first SignalR, when I built one of the first apps I ever built at AWS, I built a SignalR application because I was testing out what the .NET support in AWS was like. And so I thought, well, I'll just try and build an ASP.NET website, and I'll use something a little bit unfamiliar, like not everyone's going to be using, like SignalR, and I'll try and get it working in a service called Elastic Beanstalk, which is basically a managed service for your code. So I basically package up my code, I send it to Elastic Beanstalk, and then Elastic Beanstalk runs it. Under the hood, it's running virtual machines or EC2 instances, and it's load balancing them. But from my perspective, I just give the code to the service, and then the service runs the code. In the .NET world, Elastic Beanstalk allows you to run .NET on Windows. It also allows you to use .NET on Linux. So under the hood, it'll either use Windows or Linux servers. But the point being is that you just hand your code over, you give it a configuration, and it just deploys the stuff. It's kind of like, it's a bit like it's a PaaS service prior to sort of containers. So before containers, Elastic Beanstalk's been around since 2010, or maybe even before that. It's been around for a long time, and it's being used by lots of people to make a really simple managed service to host websites. So I thought I'll build a SignalR application, and that'll and then I'll try and get that working. And then from that, I can then explore AWS a little bit and understand it. Because when I joined AWS, I had very little experience at AWS. I didn't really know how any of the stuff worked or sat together. So I built this demo application. I then started working and figuring out how I get it working on AWS. So if you're not familiar with SignalR, SignalR is a really lovely, quite old now, framework which allows you to build real-time applications. It supports lots of different servers and client capability. So there, as I said, it's not the only way. WebSockets is not the only way to do real time. There are server sent events. There's long polling. There's other mechanisms for doing messaging, but SignalR supports all of those, or can do a fallback and lots of those. But generally speaking, if you're doing SignalR, you're probably going to be using WebSockets somewhere. In the optimal solution, anyway, you're going to be using WebSockets. And what it does is it creates a really nice sort of abstraction in C#, which makes it very easy to code against. So the SignalR is basically a capability on your web server, which is this framework sits on top of your web server. As long as the server is capable of running .NET and has WebSocket support, then SignalR will be able to work. And it makes it very simple to sort of interact with writing real-time applications. I love SignalR. It's one of the best frameworks I've ever worked on or used. And but it's a very it's not old-fashioned, but like a standard sort of client-server idea is that you have a single client and a single server, and it works really well when you've got a single client and a single server. It becomes more complicated though when you've got multiple servers in the back end and you're load balancing them. So if I were to take this application, we have support inside of Visual Studio, for example, to just right-click your project, and if you've got the AWS toolkit installed, you can right-click publish, not to the other cloud, but you can publish as well to AWS in the same way as you would publish to that other cloud that I'm not going to mention its name, just in case there's a lawyer on the call. But the blue one, that blue one, if you can right click, you can publish to that blue one, or you can publish to the orange one, which is Amazon. And generally, it will publish to Elastic Beanstalk. So right click, publish to Elastic Beanstalk. It will package up your application inside of Visual Studio and publish it to the service. And if you do that, it's all going to work. One of the challenges with that, though, the way that actually ends up being is that you end up having, let's say I want my Elastic Beanstalk scenario to have 2 servers in the back. Well, it will set up 2 servers and it will have an Elastic load balancer in the front. Well, the Elastic load balancer, its default is basically to send you to one of the 2 servers. And there's health monitoring and various things to make sure that the servers are live. But the idea is that it will route you and balance the load across the 2 servers or the 4 servers or the 8 servers that you have. If you're using SignalR, one of the things that you have to do is go into the Elastic load balancer and say, I actually want to use sticky sessions. And sticky sessions, what that does is it means that if you get connected to one server, then the next time you come to that load balancer, the load balancer will send you to the same server again. And that means that you don't have this problem of the pipe getting broken because you're actually your browser or your application is connecting to a WebSocket, but then being sent to a different server. So there's some configuration that you have to do inside the load balancer called sticky sessions to enable you to go back to the same server. And I was able to then create my application, and my application is pretty straightforward, and hopefully I'll be able to show you it briefly. That's unwise to put my Twitter directly up there. SignalR. So if there is anyone out there, if you scan or go to that URL, which is signalr.thebeebs.net, or you scan with your phone, I will just scan with my phone. Open the camera app, scan my QR code, and it will take me to a screen which says something along the lines of, please wait, please wait. And then on here, I will forward my slide here. And it will say now on the screen, like, what drink? What drink? There we go. Sorry, my lights are affecting my screen. People can choose a different drink between coffee or beer. So I'm going to choose coffee. And you'll see this is the absolute, this is like the pinnacle of my CSS ability, is the that round circle in the middle, which is like a graph. And basically as people vote, as more and more people vote.
Mine's stuck on please wait, by the way, but I don't know if it's because I'm using Edge.
Yeah, well, there'll be a reason for that. It's not because you're using Edge. It's because there was a problem with my site there. Apologies. I think we can see people voting roughly now. Okay. it's sort of working. So tabs versus spaces, and as people are tabbing or spacing, it does various different things as well. I'm not quite sure why there was a bug there, but you get the idea. We'll be able to create a Signaler application with Signaler. So this was the site that I built originally, and it basically has two glyphs, and then there's a little bit of CSS logic, which has got a CSS3 animation on it, which as people vote, it moves. So we're currently saying spaces versus tabs is an example here. So people in the Nottingham community prefer spaces just a little bit more than tabs. But that's a really simple way. Now, there's a few different things happening. Now, as I'm clicking the slides or I'm forwarding the slides, you'll see on your screen, if you've still got your application open, it's changing the question. So basically, there's a WebSocket communication happening every time I change the slide. And it's resetting the counter, and it's also updating or sending a signal out to all of you that the slide has changed. So if I actually go into my tools here and go into developer tools, ooh, gosh, network. Oh, sorry, this has got a bit of an odd. Let me refresh that. Okay, so people are voting still. Thank you very much for that. You'll see that there's a negotiate. Oh, sorry, hopefully you'll be able to see there's a negotiate. Let me see if I can zoom in. There we go. A negotiate thing which happened on the network. And that was a HTTP web request to this thing called Signaler Voting Hub Negotiate. And this basically is the negotiation that I talked about. And that then sets up this, which is a WebSocket connection. And you can see all of the different messages that I'm passing back. It's really not complicated. The way that I would do the Signaler, it's unsecure. It's not complicated. You can vote twice. There's loads of things I could do, but I'm not doing. And basically, as people are voting, I'm getting these responses, which is updating my slide. And as I change, as I change the slide, you'll see that I'm sending information over a WebSocket back to the server as well. And this creates this illusion of this real-time voting application. And it seems to sort of work at the moment. Right. Oh, well, so this is possibly one of the reasons why that didn't work as smoothly as possible. I should have played it from the right slide. Let's see if I can sorry about that. Where was I? I was over here, demo. So one of the challenges is that I probably published that Elastic Beanstalk there to multiple servers, to more than one server. And when you refresh the page, or when I refresh the page, or when you're logging on the site and refreshing the page, or you're voting, the server that you go back to might not be the same server that you went to. So I, as the presenter, might actually be connected to a different server than you're connected to. And this creates a little bit of a problem in that the messages you're sending to one server don't get relayed to my server, so they don't update the change. And so sometimes, like, I made the change of changing the slides, but then someone joined it and they got please wait. Well, the reason they got please wait was because they connected to another server where I hadn't, the message being sent, they hadn't received the message that I sent, which said move slide. So you end up with it being a little bit flaky and a little bit broken. And usually when I give that demo, I will have set up the next stage, which I didn't do this afternoon when I set that demo up, which is setting up a Redis cache. And with Signaler, you can do this thing where you set up a Redis service, and then basically when you add Signaler to your .NET application and you say services.add Signaler, you can basically connect it up to Redis. And Redis acts as what we call a backplane. And this backplane will pass the messages between all the different services that are connected. And that would have solved those issues that people would now, even if they're connected to different servers, they'll still receive the messages because it goes via this backplane, which sends it all through. Now, Signaler handles all the complexity of that. All you need to do is add this, add Signaler, add Stack Exchange Redis. A lot of people ask why it says Stack Exchange. The reason is because the Redis, the most common Redis implementation in .NET has been developed by Stack Exchange because they use it for Stack Overflow. And so it's just like become a thing that the add Stack Exchange Redis is the most commonly way used NuGet package to add Redis to an application, and so that's why that's there. It's not actually anything to do with me copying and paste it from Stack Overflow, although that's probably what I did do. And you have these opportunities of creating these things called channels. And channels are a little bit like subscriptions, and you can listen to your applications can listen to different channels. And what it means is these backplanes, these Redis backplanes, they can handle multiple applications. So you could have multiple Signaler applications all sharing one Redis backplane. But if you look at all the infrastructure that I now have, each one of those boxes on the Elastic Beanstalk section, they're EC2 instances. So they're physical servers. I've got 2 in that example, but I've got 2 physical servers. I'm paying for 2 physical servers. I'm paying for Amazon Elastic, the load balancer as part of my Amazon Elastic Beanstalk service. I'm also using the Amazon Elasticache for Redis service, which is basically a managed service for Redis. This is expensive all of a sudden for my simple little demo. I think I've got 4 machines which run the Redis cluster, or 3 machines that run the Redis cluster actually in reality. And the Redis cluster costs at least $70 a month. And that's probably not scaled to enough to be good enough to do many thousands and thousands of connections. So Signaler is great for demos, and I use it a lot for demos. But when you start to scale it, you start having to scale the infrastructure quite substantially. And there's lots of caveats and problems with that. If you're building, I'd say Signaler stuff generally works really well if you're building smaller sites. But then you have to start thinking about, well, how do I scale this? And there are many different ways, and our competitors have a very good service called Signaler in Azure, which if you're really interested in Signaler, you should definitely take a look at. But it's a sort of managed version of this. But fundamentally, they're doing the exact same thing in the background. They're just sharing it as a managed service. We don't have that exact service in AWS. So I was thinking, well, how do I get the same sort of functionality working, but at a much lower cost point? So I write for a thing called the AWS News blog, or Jeff's blog. Jeff Barr is the most famous evangelist or advocate at AWS. He's been writing blogs on AWS since 2002, I think. Since 2005, he's been writing on the blog. And he's been an evangelist for AWS since 2002. And basically, he's the most famous. He's like me, but much better and a much more a greater longevity. And he's been writing for the blog for a long time. And there's a couple of us which have been helping him write the blog because there's so many services which are being launched that they need more and more people writing for them. So there's about a team of about 5 of us which write for the news blog. And basically we cover every single thing that AWS release. We write about 750 words about that new service or that new feature with a demo. So this is the demo of it. And I got to write the API Gateway WebSockets demo about 2 years ago. And I looked at that and thought, this service that we're releasing is like perfect for what I want to achieve. And what it is it's a managed WebSocket service. And API Gateway has been a thing in AWS for a long time. API Gateway is used in lots of applications. It's got some of that's got nothing to do with WebSockets. It's basically a way of putting something up in front of your actual APIs, and then you can sort of proxy the requests which come into it to your actual APIs or your actual services. Very commonly used with Lambda functions, where the API gateway is like the web front end, and then you forward the request over to a Lambda function. Or it's often used just to sort of change the shape of an API. So if you have an API which is in a particular shape, and you want to jig that about, you can put API gateway in the front, and then you can do like lots of changes to when the request comes in. You can change where it actually goes to in the system. You can convert things like JSON to XML. You can add different parameters, sort of different variables into an XML document as it gets passed through the chain or the pipeline. And so it's really cool for sort of configuring APIs. But they then added this support for a WebSocket API. And what it means is that they will create this API gateway with you with WebSocket support, and they're going to maintain a pool of servers which are capable of doing WebSockets. And then they're going to give you a service or an API where you can interact with these WebSockets. And it means that you don't have to manage any of the infrastructure, but you just get the benefit of WebSockets. Now, I will add as well, there are two other ways that I know of in AWS to do WebSockets at scale. There is, there's GraphQL. We have a GraphQL service. You can also do WebSockets in there. It's really cool. And the scalability of that is actually much higher than the scalability of this particular service. They can do, I can't remember, but I do remember it being absolutely insane, the throughput that you can do with that. Also, there is a thing called Eventbridge, which is, there is a way of doing WebSockets through Eventbridge. I'm not going to go into that either, but there are other ways of doing, as with everything AWS, there's always one or two or three or four different ways of doing the same sort of thing. It's one of the advantages of AWS, but also one of the challenges when you're trying to explain to people. So API Gateway, it's they came up with this new program model for WebSockets. And so when you're creating your API gateway, you get to choose what type of gateway it is. I think there's 3 different types now. There's the standard API gateway. There's a REST gateway. If you don't require it to do very much conversion, it's a cheaper way of running an API gateway. Or there's a WebSocket API gateway. So when you create an API gateway, we create this WebSocket API gateway, and then we're able to do this cool thing whereby our clients now, instead of connecting to my servers and establishing a WebSocket connection, it connects to Amazon API Gateway, and then that proxies my WebSocket requests or messages into my different portions of my system. Now, what's cool about this is that from a programming perspective, we no longer have it's no longer a stateful connection. With WebSockets, it's always stateful because you always have to maintain this connection. With this new programming model, we're able to write stateless applications, and Amazon API Gateway manages all the statefulness. So it manages all the connections with the different devices. However, this requires us to change the way that we program and write our applications quite significantly. What can happen with this is that we can have lots of different clients which connect to our WebSocket. And then on the back end, we could have EC2 instances, we could have APIs, we could have other services, or what I'm going to be using is Lambda functions as the sort of programming compute to actually do the processing work. And the way it works is this. When you create a WebSocket API, you get a URL, and all of the WebSocket URLs always start with WS. So that stands for WebSocket. So instead of HTTP, it says WS. And WSS means a secure socket. And when you're creating a web API WebSocket, it will give you this thing called a WebSocket URL. And they're always secure. We don't have an unsecure version of it. So it's WSS. So when the application wants to connect to this WebSocket, it is given this URL. And so your application, your client application, your Blazor application or whatever, is just going to put this URL into it. It's going to connect up to Amazon API Gateway. And then what happens is that every one which connects to it is assigned a thing called a connection ID. And then Amazon API Gateway is going to invoke, could invoke anything, but it's going to invoke a Lambda function in this instance. And along with the invocation, it's going to pass back a thing called it's going to pass over a connection ID. And that connection ID uniquely identifies the person which made the request. What I do in my application is I then store some of this information inside of a DynamoDB table, which is a NoSQL database. So what happens is there's a stateful connection between the service and the client applications. And as I'm making my WebSocket requests, those messages or frames, as they're often called in WebSockets, they appear. So if I send 3 frames or 3 messages via a WebSocket, what will actually happen is my Lambda function will get invoked 3 times. It won't be invoked once with 3 messages. It will be invoked 3 times. So my back end is stateless in that it's invoked every time afresh, but it's invoked with this connection ID, which is the stateful element, which is passed over by API Gateway. That's cool because that means that you can call a WebSocket, then the WebSocket invokes my Lambda function. That's great. But if I'm inside a Lambda function, I want to pass a message back to that connected client. That's the thing which is the challenge, is getting the server to communicate back with the client. Well, I can post to a different URL and I can pass over a connection ID to that URL. And then that message will then get routed back to them via the service. So the service, I basically do a RESTful a post to this particular URL, this thing called a connection URL at the bottom. And it will look like HTTPS, ABDC, some random number or name, .execute dash API. Then it will say the region, which is US West 1 in this example, AmazonAWS.com/env. Env is the stage that you have. You can have multiple stages in an API gateway. You could have like test or prod, or maybe you'd use that as different versions of your API. And then you say @connections and you pass in the connection ID. And say that you want to call someone which is connected, you would pass this connection ID, and then you could basically send a message directly to that single person or that single connection. The connection URL has some features to it. So it's a RESTful, so we can post to it and send a message. If we call the URL and get a GET with the connection ID, it will tell us what the status of that connection is. And if we call delete, then it will say, all right, I'll disconnect that client from your WebSocket service. So it's got 3 different options that we can send. So if I go and create an API, I'll create a WebSocket API, give the API a name. Provide a thing called a route selection, which is basically where it's going to route, or the message to will be dependent on whatever is in request.body.message. And then a description for the API. It's giving me a failure because didn't put a T in the request. And this is a video recording, so it's even stranger that I failed. And then basically, if I've got a route, if it finds connect in that header, then it's going to send it to a specific Lambda function. And I've got 3 Lambda functions in here already. And it's going to send it to the connect on connected function. When the client sends over a disconnect message in that request, it's going to call the function disconnect. And we're going to add a new route called send message. And when anyone calls the send message link, it's a send message request, it's going to then call a function called send message. So basically, I've linked up 3 Lambda functions to this API. And the API, once it's deployed, I'm going to deploy it to a new stage called prod. Because even though it's a demo, it's going into prod. And any request which gets passed over to there is going to be sent to one of these 3 Lambda functions. So then I've got this URL, WSS, blah, 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 blah. And I've got this connection URL. So between those 2 things, now I've got this ability to create a real-time application, but I don't actually need to manage WebSockets at all myself. So my application basically needs to do this. It needs to create a JSON response, a JSON sort of payload, sorry, and put that or pass that to my API gateway. And it does this over WebSockets. So my client connections thinks that it's just connecting to a WebSocket server. And if I send this piece of data over the WebSocket and say message, send message, and then provide some data saying hello Nottingham, what's going to happen is it's going to go to that API gateway. It's going to look at that header effectively. It's going to look inside message. It's going to see, oh, send message is there. Then it's going to route that piece of data over to the Lambda function called send message. And then that Lambda function is going to do whatever it does. And what it does is this. So my client connection goes into my API gateway. And the first thing it will do by default, it will call an onConnect method. Now, you don't really need to, and you don't have to send a message or anything to do that. That's just the way the WebSockets work. They call this onConnect. And what my onConnect Lambda function does is it takes the connection ID that's passed to it, and then it stores that in DynamoDB, so a NoSQL database. So basically, anyone which connects to my WebSocket, their connection ID is going to be sent into the DynamoDB. If they call disconnect, so that could be in the client could manually disconnect, or they could close their browser window, or they could close the application. It's going to call the onDisconnect function. And that onDisconnect function is going to basically remove it from the DynamoDB. So in DynamoDB, I've got this list of connection IDs. If 100 people have connected, I'll have 100 items in my DynamoDB. Now, the reason I'm storing it somewhere in state is because Lambda is stateless. These Lambda functions run and then they stop. And so I need some way of storing this persistently. If I was using EC2 instances, I could just store it in memory on the EC2 instances like you would in a regular application or a regular API. Or I could store it in Redis or whatever. But with Lambda, it's quite common to use DynamoDB. So I'm just using DynamoDB as quite an expensive way. It's not that expensive. It's quite cheap as a service, but there probably is better ways that I could do this, I imagine. But I'm basically storing all the connection IDs. So if 10 people connected, there's going to be 10 items in that DynamoDB. And then when someone sends a message, so from the client application, they route it to send message and they pass over some data. What the Lambda send message function does is it goes to DynamoDB, it gets the list of all of the connected clients, and it basically posts that same message via that, that connection URL. It sends a message each. So if there's 10 items, it will send 10 RESTful connections. It will send 10 requests, posts to the URL, and it will basically send to everyone which is connected. There's no broadcast functionality in this feature. You have to literally loop through each connection and send them a message. So I can loop through that 100 people and send a message. This little architecture is the basis of a chat application, and this is the sort of code that I have got. So this is my send message Lambda function. And basically when a request comes in to send a message, it does this. And you'll see in the screen there, I get a domain name. I get the stage which is running on. What I'm doing is I'm just establishing my endpoint. I'm not going to go through each line, but I fundamentally query the database. I get a list of all the connections in my database. And then somewhere over here, you'll see I have a for each loop. I for each every item which comes back from the database, and I send or make a post to that request. So I say, this is the connection ID, and this is the information I want to send to that particular user. And so the send message function is just quite a straightforward piece of logic. It gets information from the database. It then sends to all of the connected clients. So hopefully we should be able to demo this. And I don't know if this is going to work or not, because I only set it up a moment ago. Nottingham.thebeebs.net. Oh, cool. So this is just a real test, simple test. It's a static page thing, and you'll see there's a URL there which it's connecting to.
We can't see anything.
Oh, crap. Oh, that's because of, excuse me. Thank you very much, Pete, because that would have been like me describing that. So if you go to Nottingham.thebeebs.net and click connect, what this little tester application that I've developed will do, should do, is it will connect to that WebSocket there. And then it says that status is connected. I can say, hello, people. And it's not working properly, but let's see if we can. Oh, yeah, there it is. Oh, someone sent me a message saying whoop. So other people have managed to get onto Nottingham.thebeebs.net and are able to send text messages. Now, this is using that architecture, that exact architecture, 3 Lambda functions in the background, and stuff is being passed forward. So if I opened up a different browser window and connected to that socket, again, window 2, then hopefully Mark Oliver here. Everyone tries to do that script, and everyone tries to do a marquee. Yeah, it doesn't. I've got those two. Azure rocks. Everyone makes fun of Azure and makes fun of AWS. That's the other one, a common thing which people do. Brilliant. Thank you very much. So you've kind of proved the point, is that there's lots of people connected here. Those 3 Lambda functions with API Gateway have somehow managed to concoct this and make it work. And what are we going to look at next? Okay. Play from current side. So that's the real-time chat. And then I got into the concept of like looking at Blazor. And I was really interested in Blazor. I've not got a great amount of time to talk about this now. I've overrun massively. But Blazor has 2 ways of operating. It's got WebAssembly and it's got a thing called Blazor Server. Now, Blazor Server is interesting, but it basically requires a server running in the background, which can sort of generate UI. So in the browser doesn't have to have any capabilities particularly. It just over SignalR, actually, it calls into this .NET executable inside or on the server, and it basically is in a very efficient way sending requests back and forth, and the user's web application, let's say, is getting updated in real time as someone navigates the site. The cool thing is, both these models, you can write the whole application in C#. With Blazor Server, what you're actually doing is the C# on the client is actually being executed on the server, then sending back to the browser. Now, for me personally, browser server isn't a solution I would ever. Blazor Server is not something I'd ever really seriously consider, because I don't care how well they've worked on this. It just seems too much like view state in ASP.NET Forms, in that you're going back to the server, rendering UI, passing it back. And I know it's a lot more efficient than that, but you are going to have issues of scaling in that you've got this single point of failure. And I think the reality is Blazor Server basically requires you to use, there's an Azure service, which you can use a SignalR service with Blazor Server. And that's really the only way I genuinely think you could use that in production. I wouldn't want to have to manage the infrastructure to do Blazor Server. So I've never really looked too much into Blazor Server other than doing a 101 demo. But Blazor WebAssembly is really interesting. You can write both the client application and the sort of the logic in C#, but what it's doing is it's executing your C# in the browser. So it means that you can start writing your application instead of using React or any JavaScript frameworks. You can just write all that stuff in C#. It's really cool. It does mean that the browser basically has to support WebAssembly, which most modern browsers do. And there's a little bit of weight that it has to download the application at the start, because it's actually importing DLLs or downloading DLLs. So there is a little bit of a jitter as an application starts, which might not be ideal. But generally speaking, I think Blazor WebAssembly is really interesting. And I was wanting to say, well, could I basically build my thing I think I wrote that in Vue.js, that coffee versus beer thing. Could I write that in Blazor? And so I went to the Blazor website and I downloaded it. This will have changed, obviously. I've just downloaded the code from the getting started when I wrote this talk originally. So .NET New Blazor, and I provide a Blazor template, and the Blazor's been now fully released, so I would be using a preview. And then I'm able to say .NET New Blazor WASM, and then give the name of my real-time app as the name of the application I want to generate. Now, you could have just, I think there's another thing which you'd pass over if you wanted to build the Blazor Server application, but I want to use Blazor WebAssembly. So I say .NET New Blazor WebAssembly or Blazor WASM. And it creates a little application for me. And what I did was I created basically a questions.json, which has all my questions for my application, and I hard coded them, as every good developer does, into my WW root. And then all of the pages, instead of editing them with JavaScript or a UI, you can use Razor. So it's pretty awesome. So I can write a HelloWorld application. There's the concept of components, like this survey prompt, which is a default component. And then you get like an on-initialized, it does feel very like writing a web form in many ways. You have like an on-initialized task, so on-initialized async. And what I do here is I just load the questions into the model. And then I have this maintain C# model in memory in the browser effectively. And as I change the model, I sort of tie my UI up to these different model properties. And then as my model changes in C#, so will my HTML. That will get updated. So I add all of my questions to this variable called questions. And then in my Razor page, I can say, okay, if questions is null, then add loading, else draw a table. And it draws a table of the title of the question, answer 1, answer 2, answer 1 count, answer 2 count. So this is the basically the screen for the presentation of it. Yeah, so you get this opportunity to say, well, if questions is null, then show this, if it's got questions in there. And obviously, as I just add questions to my object, if I add or delete them, my UI gets updated automatically in the browser. So I have this sort of piece of code which says, for each question, instead of just printing all of the questions out, I'll only want to print the one which is the current question. So I only want one at a time on the screen. So I just have a really sort of crude way of having this variable called current question. And if the current question, as I loop through all the questions, is the current question, then I will show that one, else I will not show any questions. I then add 2 buttons. These are HTML buttons. And you can see they've got this on-click parameter. And that's actually wiring it up to a C# function. So I say previous question, next question. And then I've got 2 handlers or voids, one for next question and one for previous question. And if you press either of those buttons, it's going to pass to the next question. And what that will generate is then that little bit of code is effectively going to create this little application. Now I have questions, tabs or spaces, answer 1 tabs, answer 2 spaces, and I can click next and previous. And using C# and no JavaScript, I'm able to create this sort of interactive application, which is cool. So for the voting screen, so there's 2 screens in my application. There's a voting screen, which basically shows the options to people. And then there's a way that people are actually able to vote. So for the voting screen, it's a very similar thing, but this time I want 2 buttons so that people can press the buttons to vote for one of the 2 options. So here I have a screen which does exactly the same thing, but then instead of on next, it says on click vote answer 1 or vote answer 2. And I basically wire up the answer to the question's answer. And so I get this now on the votes screen. So people can vote for different numbers and they can move questions. Cool. So now I wanted to connect it to a WebSocket. And this is where it starts getting a little bit complex. When I first got into Blazor, the idea was, okay, you've got HTTP objects and you've got .NET objects and .NET things. So, well, if in .NET, if I was writing a console application, I wanted to connect to a WebSocket, well, I would just connect to a WebSocket because .NET can do that. But that didn't work when I first used Blazor. So I came up with this really convoluted way of doing it. I'm going to show you just very quickly what this is, and then I'll show you the actual solution to how I resolved it. So you have, basically I manage the WebSocket connection in JavaScript, and then I invoke JavaScript from the C#. And this is what this JR runtime invoke async stuff is all about. Actually, I won't show it because I'm running out of time. But fundamentally, in my application, I added some extra code. Rather than just having, send message, I now have this new Lambda function called vote. And this Lambda function is basically, here's my Lambda function, and it basically stores the votes that people make into another table. And then when someone votes, this was the code that I used to have to write. And what really annoyed me about this in Blazor was that I'm basically trying to use the browser's WebSocket connection. So I ended up having to write just tons and tons of JavaScript. And then creating C#, which is invocable via JavaScript. And it's cool that you can do this, that you can interrupt C# and JavaScript in using WebAssembly. But what's not cool about it is the fact that it just requires you to write loads of JavaScript, which is kind of not the point. But then I was able to basically build this simple solution where you can vote now for tabs or for spaces. And you'll see that in the network section of my browser, you can see that there's messages being passed back and forth to the WebSocket. As you'd expect, as I needed or required it to do. So if I have two browsers side by side, and I've got the application there, then if I'm voting for one in one on the vote screen, then on the question screen, you can see the questions and the responses coming back in. So we've got a real-time application sort of set up and working fundamentally. Now, if you're interested in like looking through this code, because there's obviously you want to have a little bit more of a deeper look into it, then I have this URL. I've actually got I've been working on this all day today, so I've got to commit what I've been working on today. But it's on github.com, the Beeb's Blazor voting demo. You can download it, and it has all the sort of code, not only to show the Blazor stuff, but also to provision the infrastructure that it sits on. So one of the cool things though, and this is the last thing I want to show, I want to make 2 points. One is that earlier today, Pete was talking about JetBrains, and they're saying JetBrains were sharper. One of the things that JetBrains do, which is really good, is Rider. And this is the browser. This is Rider's the editor, the code editor I use like all the time now. It's really good. I would recommend trying it. We also have an AWS plugin for this if you're interested as well, but I'm not going to go into that. Now, what they've done inside of Blazor now is that whenever I create WebSockets in C#, that's the way I can do it as I'd expect to be able to do it. So they have this concept called a client WebSocket. So you'll see a client WebSocket, and it creates a new WebSocket. And then I have, when the page loads, I have await sync, WebSocket connect async, and it connects to a WebSocket URL. And then basically I've got this thing called the receive loop. And the receive loop works basically by it's then able to receive messages. So my application is basically listening to this WebSocket for new messages. And when new messages are received, it will change the objects, the C# objects, which will update the UI in my website. What's cool about this is that there's no interop between JavaScript and C# anymore. I'm writing all of this in C#. So my whole website, my whole application is written, all the business logic, everything is written in the client in C#, including the WebSocket communication as well. So I'm able to, not leave the language of choice, which is C# in my instance, and write everything directly inside of Blazor, which I love. But then all of the server-side complications that you have to deal with, that's all taken away from me because I'm using this managed service from AWS to do all of the complexity when it comes to sort of WebSockets. And so I can take this application, and my idea is that I'm going to build it into a very similar voting application that you saw earlier. And I'm still developing this and still working on this. But the concept being that I'm going to get to a point where I will have a voting application which I can use at events, which will be extraordinarily highly scalable, but will only ever cost me when people use it, because I only ever pay when someone actually executes my Lambda function or someone visits my page. Because the cool thing about a Blazor WebAssembly application is that once it's built, it just is output as static files. So I can host a Blazor application in an S3 bucket or in Amplify console or some static web hosting service. I don't need any complexity. I don't need any web servers or anything like that to manage my application anymore. And my all of the complexity of the WebSockets is not handled by me managing EC2 instances or virtual machines, but instead just using this managed service. And from a Blazor application, I'm also, my tendency is to start using other managed serverless services. So if I needed to do, let's say, identity, I could use a service like Cognito. I don't need any servers to be able to run that. So from my static pages I could call into Cognito, and I could enable logins to my application, users to my application. So I think this model of building Blazor WebAssembly applications, putting it into basically creating static websites, hosting them on really cheap, inexpensive things like S3, and then using serverless services, which you only pay for when they're used, means that I can build this sort of voting application, use it once a month, and only pay 50 pence for the whole of that, knowing that if for some reason it scales massively to 5,000 users, which is massive in the example, but it could equally scale to hundreds of thousands of users, then I'll know that I actually don't have to do anything to support that scalability. It will just work, because things like S3 will be able to handle the load of handling up the Blazor website, and the WebSocket service is going to be able to handle all of the concurrent WebSocket connections. So yeah, that's the little sort of project that I'm working on. It's building a Blazor application, connecting to AWS API gateway, and I've now got it to a point where I'm not having to write any JavaScript at all. Although the version that I showed at NDC earlier in the year, most of it was JavaScript. But now we're getting to the point where you can actually write a lot of this stuff purely in C#. And that is everything from me. Just to say, if you are interested in AWS and you would like to know more about, if you're interested in AWS and you want to, I'll just put it on my front screen, that'll be easy enough. Why did it not play from current slide? If you wanted to try with, I don't know what's going on. I do not know what's going on with that. Never mind. Can I find the Beebs on anything? That's my passwords. Yeah, I'm on a Mac, so I don't know what's happened with my. Oh, here we go. That's what the problem is. Right. So, no, still. The Beebs, I am at the Beebs. You can see it somewhere on the screen there. It's over there. You can see at the Beebs on Twitter. If you just DM me, I will send you a $50 voucher for AWS. So you can use that to explore some of these things yourself. And with that, thank you very much.
Thank you very much. Carl asked earlier about hosting costs, and you just said 50p. Is that 50p because it's cheap, or is it really 50p?
Well, it depends, obviously. Let's say for the actual purposes of what I do which is I'm building a voting application that I'm going to use at an event with probably a maximum of, the biggest crowd that I've ever spoken in front of is 5,000 people. So, no, actually, it's more than that, because I spoke at NDC, that's not NDC. I spoke at the New York Summit. It was 14,000 people. It could handle quite easily 14,000 people. And you would be paying for, the things that you would be paying for is the S3 hosting. Well, that won't cost anything for that. Sort of to serve 14,000 pages won't cost you anything. It costs you something, but like so little that it's not even worth it. You get 1 million invocations for Lambda every month on the free tier before you start paying. So I don't think that voting application would generate. I only use it once a week. It wouldn't generate that many invocations. And if you did, the invocations are quite inexpensive. The most expensive portion of that would be API gateway. I'm not completely sure of the costs of API gateway, but that would be the most expensive part of it. And the API gateway, the socket service. But if you compare it and contrast it with even me just building a virtual machine with SignalR, it would be, it's significantly less. And what I'm finding is that this is just one application I'm building at the moment, but I'm finding, generally speaking, I'm tending towards building serverless applications for almost everything, purely because of the cost. That you can really reduce the cost for the way that you can build things. I think it was Red Nose Day. The Red Nose Day team, they moved their application from a standard architecture to a serverless architecture, and their infrastructure costs, they saved. I think they went from, I don't want to quote the numbers directly because I can't remember them, but it was something like their Red Nose Day, the online TV thing. That the costs for that month, whether on TV, was about £80,000. And moving to a serverless architecture, they reduced their costs to somewhere in the region of, I want to say 15. It was something like 90% cost reduction in hosting charges for comic relief. So just by, and actually they were able to increase their throughput and increase their capacity and increase their scalability whilst massively reducing their costs. So depending on the architecture, depending on what you're building, like looking at serverless options is a really good choice. Even if you're not looking at AWS and you're looking for other companies, serverless is a really good way of, an interesting way of thinking and re-architecting applications. The problem you'll see though, is that I had to do an awful lot of, I completely had to change the programming model. That wasn't me just lifting and shifting my application. That was a complete rewrite. had to rethink the way that it was working and the way it was doing it. But, it was beneficial from the cost point of view.
Yeah, it looks like Jess has put a link in the chat to that comic relief, 93% reduction from 80.
Oh, get in, Jess. I was really worried that it was I said 90% and it was going to be like 80. I was saying completely wrong. 93 is good, right?
I was lucky enough to see it at AWS Summit. It was a good talk.
Oh, thanks. It was a good talk. She was great.
The video for it is on that link as well. Unfortunately, it's a Medium post, but the whole YouTube link is on there.
Cool.
Awesome.
That was actually some time ago now. That was probably like a year and a half ago now, but it feels
longer.
Like...
When did we last get to see people in person?
Yeah, exactly.
March 2019, they're talking comparisons there. 2015 was $83,908. March 2019 was $5,393.
Oh.
That's massive.
I was a little bit conservative with my numbers then because I thought it was like, I knew it was like in the 80s and I knew it was somewhere significantly less. So yeah, that's huge. But what is cool about them as well, if you look at the talk, they talk about they were able to onboard multiple payment services as well. So they used to have just like a single payment service, but they're actually able to fall back onto different ones depending on who was able to service the different requests and stuff. So they actually massively built their resiliency as well. Now when that talk was wrote, and when I first got into serverless just 4 or 5 years ago, it was all about one execution of a function or a Lambda function. And that's basically what I showed you tonight, was me executing one single Lambda function. But what we're seeing customers do now is build really complex systems with serverless applications. And you can build pretty much any kind of architecture now with serverless. Lambdas calling other Lambdas. And my colleague, Alex Casablani, writes a thing called Lambda power tuning, which allows you to experiment, basically upload your Lambda packages and then experiment to find the very cheapest way of running that Lambda function, because different Lambda configurations cost different amounts of money. Excuse me. And so he's got like a tuning tool which allows you to figure out the best price point for memory and CPU based upon your workload. So it's really advancing at a massive pace, serverless stuff. And I think it's probably one of the most interesting aspects of working in cloud computing at the moment.
Cracking. Obviously, feel free to come off mute. At this point, you can come off mute and ask a question if you have one. Or lurk. That's fine. You wowed everyone. I was just scrolling up through the list of chat stuff to see if there's anything that I missed. Nope. So that's cool. Yeah, thank you very much. Okay, then
We should be good. There we go. There we go. Ooh. No idea why that stopped working in the course of listening to you, Martin, but apparently it did.
It was that big.
Right, there we go. So, hello, everyone. I just waved there. I don't know why. No one can see me. You can tell it's just stopped being BST. My brain still thinks it's 9 o'clock at night. But welcome to Zero to Mobile Hero. This is our very whistle-stops tour of a quite in-depth topic, but hopefully we'll have some fun today, and you'll go from, if you're at zero, no one's a zero really, but yeah, we can all hopefully be mobile heroes by the end of this talk. So this is your average geek. They've had an idea, you know what we're like. We've always got ideas. No offense to anyone that doesn't like being called a geek, nerd, dork, intellectual, whatever term you like. Yeah, this is just your average .NET programmer who's had an idea and thought, oh, I want to do something that involves making a mobile app. You know, we've all got, these days, most of us have got smartphones in our pocket. Back when we were actually allowed to leave the house, we might have wanted to sort of make something cool to show off to our friends because, you know, why not? And so, you know, we've decided, right, okay, I love .NET, potentially. I know there's some people in the YouTube audience who aren't .NET developers, but that's okay. We're going to pretend that you are for the sake of this evening. But yeah, so you love .NET, you know, this is a .NET user group, and you want to make a mobile app. And so, you know, you might want to start doing a bit of research into what your options are, and you will have come across something called Xamarin. So Xamarin is a cross-platform cross-platform application development framework now owned by Microsoft, which is essentially a thin .NET wrapper around the native SDKs. So it allows you to write .NET code that you know and love, but it actually gives you access to the all the native SDKs underneath. Once it starts to be compiled, it uses all the native build tools, build chain, everything, all the native code right down in the lower depths. And so, you know, you still get the same experience. Once it's deployed, you wouldn't actually know it's any different from being written in something like Kotlin or Java for Android, or Swift and Objective-C for iOS. Now, you can see here from this diagram that you've got the iOS, Android, and Windows options. Now, the traditional Xamarin approach, as you can see here, uses shared business logic. You then got the UIs, as I said, declared for iOS, Android, and Windows. Now, Xamarin does actually support more than just mobile, which is why I've called it an application development framework. You can also do TVs, certain TVs like Samsung's Tizen and like Apple TV, watches, fridges, fridges, IoT devices, you know, all sorts of things. Pretty much, if .NET runs on it, you can do Xamarin with it. And what's great about Xamarin is that it allows you to do, as you can see from the diagram, shared business logic. So that means that you've only got to code it once for your business logic. It uses .NET Standard 2. So if you already have, you know, it might be that you've got some kind of like data access layer or something that's a .NET Standard project, you could just include that and start using it in your solution. You can also write the shared business logic. So it might be a brand new project as part of the solution, but it'll be .NET Standard. So it interrupts quite nicely with other .NET projects. And it means that you've only got to write the code once, but deploy it to lots of places. So that's already saving you time. And, you know, in a cutthroat world where we all want to get to market quicker, it saves you a lot of time. Today, we're going to focus on mobile only, just because that's kind of where the history of Xamarin comes from. It started out life as part of the Mono project with Mono Touch, and then it slowly evolved over the years, and before it kind of became part of the Microsoft umbrella in 2016. But the problem with this traditional approach is that you've still got the individual UI layers. So you still need to know how to do the iOS UI, which uses something called storyboards, Android XML for the Android side, and then a XAML dialect for UWP. So you still need some logic for some knowledge for these different UI types, which adds some time on. So what Xamarin introduced quite a few years ago now is something called Xamarin.Forms, which is my personal favorite. So you'll see here, it's got the same shared C# backend, but then you've got shared UI code as well. So using either XAML, but a different dialect of XAML to UWP, or Encode, is like you can share the UI as well. So it's even quicker to get to market, which is fantastic. And, you know, I really like it for that reason, because it's nice and simple. But one of the other cool things about Xamarin is that it's not just C#. So you saw C# mentioned in those diagrams, but is anyone in chat musically inclined that can tell me what we're looking at right here?
F#?
Yes, there you go. Yeah, so it's C# and F#. So I've touched on before the fact that technically Xamarin is .NET. Most people associate it with just C#, but it does support F# as well. And this little character at the bottom is sort of our average geek who sat there contemplating, oh, you know, I've got all these choices now. What should I do, C# or F#? So, you know, it's just a bit of fun. When I made this slide, I was learning to play the piano again, and so I just got inspired to bring this image in, because why not? So we know about how to we know what Xamarin is now a little bit, and we know that, you know, it can run on multiple devices. We know that you can do it in either C# or F#, but But then how do you actually go about, doing it? What do we need to get started? So we have 3 choices, and I can maths, I promise. There's move the mouse and it's doing that right. So you've got 2 choices. Well, 3 choices. I can add up, I promise. There's a reason for it. So on the left, you've got Visual Studio for Windows. So if you do, with the Visual Studio installer, there's under the workload section, there is a mobile workloads with Xamarin box that you can tick. If you make sure that you've got that workload installed, it'll give you all the tools you need to get started. So that's not just the Xamarin like templates and stuff, but also the Android SDKs to deploy to Android, anything that you need for iOS as well. And we'll come on to a problem in a minute, which we'll talk about. But yeah, so it's Visual Studio, it works out of the box, it's pretty easy. I know a lot of people in an enterprise will use Visual Studio for Windows, so that is the most common. But as I mentioned, there is a limitation, and that's to do with iOS. So with iOS and Apple specifically, they've insisted that in order to compile iOS applications, you need to use Xcode build tools, which is only available on a Mac. So if you create a project for Xamarin or Xamarin.Forms on a Visual Studio for Windows, it will create the iOS project for you if you tick the box. However, you won't actually be able to build it unless you start using a Mac in parallel. So there's something called a Mac build agent. So essentially, if you've got a Mac somewhere on the network that your Windows machine can talk to, whether that's a Mac Mini, an iMac, a MacBook, or even if you don't own an actual physical Apple device, like Mac OS device, not just Apple, there's also services like Mac in Cloud, which allow you to essentially rent computing space to do the builds for you, and then you can potentially use other services to access it and do it like that. So you're not completely limited, but it is easier to have a Mac device on the network. But what's super cool is that Microsoft has done a lot of work with the Xamarin tooling. And so with the Mac build agent, you can actually there's a remote simulator that comes with Visual Studio. So if you've got a Mac on the network and you've got the build agent connected, when you build and debug your iOS application, it will actually bring the simulator window over to your Windows machine. So even if your Mac Mini or whatever device it is sat in a cupboard with no monitor attached, you can still do your development and debug it locally. Plus, they've introduced something called recently called Hot Restart, which means that as long as that you can actually, if you've got the Mac build agent connected just once or whatever, you can plug your iPhone or iPad or whatever it is directly into your Windows machine and actually debug your iOS applications from there. So you can use physical devices without needing to connect to the Mac, which just makes the whole process easier. Plus, they've brought in extra windows. So now if you've got to do something like accept a new license agreement or install some extra tools, it will actually say to you on the Windows machine, oh, hey, you're trying to build this app, but you're missing this or that. It will allow you to accept those things on your Windows machine without touching the Mac and give you a progress bar. So that's just really helpful. It just means that if you're a majority Windows user that's making iOS applications, you don't need to spend too much time sat on a Mac. Then on the right, we have Visual Studio for Mac, which is started out life as Mono Develop, then it became Xamarin Studio, and then post acquisition, they turned it into Visual Studio for Mac, and they brought in things like the Roslyn compiler and ability to do things like .NET Core applications. So although feature parity is not complete at the moment, it's still very, very close, which makes it a really great IDE. Now, unlike with Windows and doing Mac development, with Visual Studio for Mac, there isn't an idea of like a Windows build agent, so you won't be able to build and run Windows applications, unfortunately. But that's okay. It happens. What I often do if I need UWP applications, because I'm a majority Mac developer, is that I will just maybe go on a Windows machine, create the project, so it has UWP, then push it up to version control, then bring it down and work from there. It is also possible to add your application retrospectively. So say you've got your certain platforms targeted with your project, you can then later on go, oh, I want to add UWP to it, add that in, and with a few extra lines that you just have to do to set it up, it works. There's blog posts about it, and I've even done the same on a project on a stream. So I can share that with anyone who's got questions about it, should they want to do the same. Now, as I touched on before, there's 3 IDEs, but you only see 2 here. And the third one we actually saw Martin use before, which is Rider. I've not put it on here because I've not used Rider for Xamarin development particularly. I know you can do it, and I know some people who pretty much use Rider, like Rider's their main IDE for Xamarin development, but I didn't want to pop it in because I've not used it myself too much to say much about it. But yeah, overall the experience is pretty good. So because this year's not been stressful enough, I'm also going to live code during this talk, because why not? So we're just going to switch over to Visual Studio and I'll bring it over here. So close that for now. If my Mac keeps up, there we go. Right. So what we've got here out of the box, so let me zoom in, is, there you go. So this is a project. I called it D flat because essentially C# and D flat in musical notation are the same note. But yeah, so when you create a blank Xamarin.Forms project out of the box on Visual Studio for Mac, you get 3 projects. You've got iOS projects, so that's what we call the platform specific. So if you've ever done any native iOS development, you'll see that this structure looks very similar. It's just that they've got C# extensions and not something like, Objective-C or .Swift or whatever they are. But it's pretty straightforward. There's not much going on here. Because we're doing Xamarin.Forms, which is the shared UI, you don't really need to worry too much about what's going on at the platform level. But essentially, you've got the app delegate, which is where it starts. And again, out of the box, it just initializes Xamarin.Forms and then says, load the application, and refers to app, which we'll see shortly. Go away. Zoom. There we go. And then the other things of note, so there's resources, which is the UI, but nothing's actually going on with it. Entitlements.plist, so that's pretty much the permissions that says what can you do with the application. So you can start adding things to it. So it might be, oh, you want access to, I don't know, location or something. That's what entitlements is for. Then info.plist just tells you things about your application. So the identifier, the name, all stuff out of the box. But yeah, it's just, if you've done iOS projects before, you'll see that the structure is identical. It's just with a C# flavor because it's just a wrapper. Then just like with iOS, Android's the same. So you have exactly the layout you'd expect from a native Android project. You've got main activity, which is the entry point. It does exactly the same again, where it initializes Xamarin.Forms and then calls this new app. So this load application is just basically saying, well, rather than looking locally for a file in this project to know where to start, we're just calling app instead. An app you'll find in this shared project. So this shared project, so we call it at the top, is a .NET Standard 2 project. And out of the box, it will come with these folders and a couple of files. So app.xaml.cs is where the entry point is. If you've ever done anything like ASP.NET before, you will recognize this whole idea of partial classes. So for every XAML file, it gets a partial class or code behind file, as we call it. So for the sake of app.xaml, the .cs file has the app that we saw referenced in the project specifics. So the project files, the platform that you're running it on will go, oh, hey, okay, here's app. It initializes the UI components, then sets this new page, which you saw here. Then there's some other stuff going on that you don't need to worry about too much. Then app.xaml is just application resources. So you can do stuff like application-wide theming, which is pretty cool. So it means that, you can just say for every button, give it this style, and then you don't have to do it in line for every every component. Then the exciting stuff happens in main page. So let me right, there we go. So this stuff, if you've not seen XAML before, might look a bit scary, but don't panic. It's just so XAML stands for extended application markup language. So it's got sort of, tag style syntax, a bit like, XML or HTML. So the content page is just the root type of page that you get in a Xamarin.Forms project. It then declares what it calls namespaces for some extra bits. And then we've got the stack layout. So stack layout, as you imagine, is, it's sort of best way to do this. It would be like one on top of the other. So each item that you add, by default, it's vertical. So it's just a vertical stack. So every time you add a component, it will just be added below the previous one. You can also set the orientation to be horizontal, or you can do other types of layouts like grids or relative layout. But we're just going to keep it simple. So a lot of people, when they do their first application, will do something like HelloWorld. But we're cooler than that. We want to show off to our friends, and, we'll all pretend that while stuck at home during lockdown, we've been going out and doing lots of exercise. So one of the things we might do, why not, is play basketball. And maybe you want to keep account of the things that you've been up to. So we can just do a really simple counter app. So what kind of things you want on the counter app? So we can do a label. We'll give it some text. We'll start it off with 0. We'll give it a font size so we can read it. We'll make it nice and big. We'll also give it a color. Let's pick a good color. Let's do lavender. Why not? Because lavender's relaxing and it's evening time. And then we'll give it a name, because we want to be able to reference it later to say, well, we want to change the value of this. So we'll say it is the counter label. Then we can close that off. So it's self-closing, a bit like you might see in HTML. And then we want a button that says, hey, make this number go up by 1. So we want the text on the button to be, I don't know, increment. Oh, no, actually, we're doing basketball, aren't we? I scored. And then we'll do click. There we go. So clicked, as you imagine, is just saying, when I click on this button, what happens? So we'll just let it autocomplete for us because it's easier. We'll set the font size to be, again, nice and big. And then we'll give it a background color, because why not? We'll do my favorite, which is CC0000, which is the shade of red, and close it off. So that's all we need on the UI front, just to make this counter. And then, as I mentioned, every XAML file has a code behind. So this is linked to the page. You can see it's already made that button clicked event handler that I asked it to make. And then you can see it's created 2 arguments or parameters, whatever you want to call them. Don't worry too much about these. The sender is essentially what's called it. So in this case, it would be the button. But sometimes you might have something that's reused. And so you might want to cast the sender to something when you in the code, or you just leave it as is. Then event args is just any extra data, but this is a very simple app, so you don't need to worry about it. So this is a counter. What stuff do we need to know about? Well, we want a count. So we'll just set that to 0. Then we'll say that when it's clicked, we want the count to go up by 1. And then we want to update that label. So we called it, can't spell, counter label. There we go. Dot text. We're going to want it to be that count, except count is a string, not a string, it's an integer. So it's a number. So we're just going to make it a string. There we go. Cool. So we should be able to deploy that now. So what I'm going to do is I'm going to set this to something called multi-platform. So this is a run configuration I created manually so that it actually deploys them to both platforms at once, so that we don't have to stop and restart to see that the application looks the same on both platforms, just from one set of code we wrote with about 5 lines of code. So just wait for this to deploy. See what it does. There we go. So let's move this over here. So this is iOS. So iOS, I didn't change the text color. So you can see it's got that default horrible blue color, but because that's a native iOS button, I didn't change it. So you get what you get out of the box of iOS. Android is the same. Android has black text on the button. So you get black text on here. We can't see the numbers because I chose a terrible color, but we can quickly stop that. So there is something in the Xamarin.Forms now called XAML hot reload. So you can make changes to the UI and save the file and it will automatically update. I've just got a bug at the moment in my Visual Studio for Mac, so I can't do that. But we're going to change this to something a bit more obvious. So brown seems really boring. Saddle brown, why not? I don't live that far from Saddleworth Moors, which is quite famous because it had those sketchy things happening years ago. All right, so let's just build that again. Shouldn't take long. Yep, there you go. And now we can see it again in action. Cool, we can see it now. So if we hit the button, both applications, boom, just like that. A few lines of code is working on multiple platforms. It'll be the same on the UWP if we were doing this on a Windows machine. So I think that's pretty cool. You know, it's taken barely anything at all. And we have two applications, the same application running on two platforms. So that's the C# version. But as I said, it also supports F#. So in true Blue Peter style, we're going to load, is it that one? This might be the wrong one. I tried to rewrite this updated, but my F# not very good. So we'll see if this works. If it doesn't, you just have to take my word for it, but then we'll have a look through the code in a second. Don't let it frighten you. Oh, yeah, no, wrong project. So the thing with the F# version is that it uses a library called Fabulous, which was started by Don Sign, the great benevolent dictator of F# while he was, I think he still is, but was on secondment with the Xamarin team at Microsoft. Because F# does support Xamarin.Forms out of the box, but it just wasn't the nicest developer experience. So he actually developed a whole project just to make it nicer for people. This project uses its predecessor called Elmish for Xamarin.Forms, which is based, the whole thing is based on, is it Fable, the Elm web project? And so, yeah, this is I tried to, as I said, try to update this with the Fabulous project, but quite a lot's changed under the hood. So if you learn one lesson from me tonight, it's that don't ever leave projects 2 years before you update them. It's painful. Oh, everything's not working tonight. Right, you'll have to just take my word for it. I promise it works. I've got videos, I can prove it later to show that it works. But essentially, it's the same code. So if we have a look at that main page like you saw before, some of the syntax is ever so slightly different. But apart from that, you've still got a label, you've still got a button, you've still got the text, font size, and the color. And then the main stuff is happening in this app.xaml.fs. So F# uses the model view update architecture. So this file is structured slightly differently. But essentially, you have a model which holds the state of application. So in this case, it's the count. The message is just what things the application can do. So in this case, you can either increment or decrement. Then we just have app again, like we saw in our C# version. We set the count to 0 to start with, and then we just do the, hey, well, if you call increment, then give us a new model, but this time the count has been adjusted to be +1 or -1. And then the views just sets up the page, and then you start the application. There's a link to the link at the end of the slides, which has links to things like the GitHub repos for this. So don't worry too much about the code. If you want to look at it in more detail, you can look at it offline. You know, sometimes it can take a while to get your head around this stuff if you're a C# developer. But yeah, it does work most of the time. And it also would look exactly the same. So we've done both demos. So now I want to talk about the story. So, you know, we've looked at the counter application, and, you know, that's pretty simple, and it only took us a few lines of code, and boom, we had a multi-platform application. But there's more things that you can do with it. And I don't know how many people here are fans of board games, like proper geeky board games. But a couple of years ago, I played a game called Twilight Imperium, which, if you know it, you'll know that the game takes anywhere from 10 to 12 hours to play. It's a proper all-day dedicated game. But it means that you have quite a lot going on. It's a space-based game where you pick a race to be at the start, or like a faction to be at the start of the game, and it's like battles and there's rounds and all sorts goes on. But essentially, I got into a battle with somebody where I said to them, right, you can have the next technology that I research if you don't raid me, if you leave me alone and don't invade me and blow up all my ships and all my cool stuff. And they nodded at me. And I thought that meant, cool, I'm safe now. I can sit back, I can relax, maybe take a swig of my drink and just go, it'll be all right now, my ships are safe. Yeah, no, I read that one completely wrong. And a load of my stuff was blown up by the next round. So it made me realize that I'm really not very good at reading people. And so not long before I played that game, actually, I went to a Azure Global Bootcamp Day, that blue cloud competitor that Martin didn't like to say out loud. They had a global bootcamp, which is all about AI and stuff. And so I learned about something really cool. And I realized it would come in useful. And what was that really cool thing? Something called cognitive services. So the Microsoft Docs marketing spiel says Microsoft Cognitive Services, formerly Project Oxford, are a set of APIs, SDKs, and services available to developers to make their applications more intelligent, engaging, and discoverable. I mean, if that's marketing spiel, what does that even mean? So we're going to go over to our dear friend, the internet. Let's hide my bookmark because it's not very interesting. So this is Azure Cognitive Services. So essentially what it is a set of AI machine learning related products, which make it much, much easier to get started with anything AI related. It lowers the barrier to entry. A lot of the heavy lifting is done for you by Microsoft. And it means that you can get started in surprisingly few lines of code to bring AI to applications. And it comes under what I like to call the 5 pillars of awesome. So you've got decision. So that can do, content moderation, personalizers, and all that stuff. Then there's language. So that's helpful. You can help with language understanding, Q&A, text analytics, even translation, which is helpful. I know a few people have used this in stuff like talks or Twitch streams, so that they can give you viewers the opportunity to change to their native language during the stream. Then speech is, speech to text, speech to text and text to speech. Can't talk today. Speech translation, even speaker recognition. And what's cool about these is that, again, it's all, a lot of the heavy lifting's been done for you. So it's not just with making it easy to get started with, but also, if it's stuff like speaker recognition for celebrities, you'll find that they've probably done all the training for you already. So there's all this features there for you out of the box. Vision. So that's anything from, stuff from images, videos, or digital ink. So you can do content in images and videos. So that's like known stuff. Then custom vision means that you can actually pass it in anything you want. A couple of years ago, I did a fun YouTube video where I actually went into the Azure portal, which is their like cloud services portal online, and trained a model up on pictures of House and Wilson from the TV show House MD, and it will tell you whether it's House or not. Then there's face detection, form recognition, even in a video indexer, and then there's even stuff for search. So there's all this stuff that you have access to really easily. And the reason I love it is because, as I said, it has a really low barrier to entry. And I introduced it into these talks because I was like, do you know what? These two, Xamarin and Cognitive Services, would go really, really well together. And so, as I mentioned, I realized that I'm rubbish at reading people. And I was lucky enough to go to Build in 2018, which is Microsoft Developer Conference. And while I was there, I saw a talk where someone was saying, oh, you can do text analytics, and here's a pretend interaction with my boss. Is he happy with me or not? And I thought that he wasn't, but it turned out that he was. And I was like, yeah, I can't read text either. So, as some of my friends watching will attest to. But yeah, essentially I was like, right, these could go together. So I developed something really snazzy I like to call Body Language Assistant. So this is an app, terrible name because it does more than just body language, but it's an app that I put together which uses both. So I'm going to demo it first, and then I'll do I'm conscious of time, but then I'll do a quick overview of how it works. As I said, I'll share the link afterwards, which shows how it was put together, like with the links, so you can look how it's put together. So let's just share my screen quickly. Screen mirroring. There we go. Just wait for it to connect if you want. There we go. So once that comes up, I'll drag it over so you can see as well. Because I'm sharing Zoom, my internet's like, oh, I'm going to be slow. There we go. So just going to go into, I'm that organized. I have folders for everything, even on iOS. But here is my Body Language Assistant app. So it's nothing that snazzy, but it's just, I made a menu page. It might be poor UI, but it just worked. So we'll start off with analyze sentiment. So this one is sentiment in text. So we can do I love .NET. So that should go off to the cloud and say, hey, there you go, split second. It's already done the analysis for us, just like that, boom. Now, of course, it doesn't come back with singing zippity-doo-dah at you, but that's just my sense of humor. You know, if something's good, you want it to be really obvious, and singing is a really good way to know something's happy. I know that's not true. There'll be some very angry screamo songs that aren't quite so cheerful, but get the idea. But yeah, it took a split second to get some feedback on what the sentiment was and then display it on the page. If we do something negative, like, sorry, Martin, Amazon pays no tax. Let's see what happens. I can't type. Tax. This might not know, but it might come back as neutral. No, it thinks it's a good thing. Okay, I can't say I hate .NET because that's not true. I hate JavaScript. I don't, but I don't understand it, and we fear that which we do not understand. There we go. There we go. It knows that that's a bad thing. So it comes back, says sucks to be you. Of course, that's very sarcastic. And again, that's my sense of humor. You know, because it's computer trained, obviously one of the limitations will be that it can't detect sarcasm. But, you know, it's a computer, what do you expect? You know, it can only go on, you know, obvious binary, yes or no, positive or negative. There are other sentiments in there, but essentially the main ones are happy and sad, or positive and negative. So that's the text analysis. But what about the emotion? So I'm going to use, so we've got the option to either take a picture from the camera or pick the gallery. I'm going to take a picture from the camera because I took, was it yesterday or the day before, I took a picture of my dinner to send to a friend, and it was a meat picture, and there might be some vegans or vegetarians in the audience. So we're going to be considerate and take a picture instead. So let's have some fun and pull a silly face. All right, that looks terrible. We're not going to use a different picture to that. That'll do. Not the most flattering photo, but it'll do. So that will go off. It will look for the face if it's not too blurry. There you go, and came back very quickly with a response. So in this case, it thinks it's neutral, but you know, we could do a sad face. It's not the most perfect code, so you have to go back twice, otherwise it tries to redo itself. But we can do things like sad faces and see if that works. See what it thinks that is. There you go. So the score of 0.995 might seem a bit strange. That's the number that you get back because it's a probability score out of 1 of the likelihood that that it is that thing. So essentially, normally you just times that by 100 to get a percentage. So in this case, it's 99.5% sure that I'm sad. I'm not, obviously. I'm thrilled to be talking to all of you, but for the sake of the picture, it works. So that's the application in a nutshell. Now we can actually have a look at how it's put together. So we can kill my iPhone. There we go. Not literally, of course. So I won't spend too long going over this, just because, as I said, I'll, conscious of time, and you can, a lot of this stuff, it's easier to just look through at your own pace. But I'll just see if it will let me switch to this, and I'll just give you a quick overview of how it's put together. And then if you choose to go through it later, you'll kind of know where to poke around. So let's just close all of these. So again, you've got the same kind of project layout that you saw before with the iOS and Android project, but then this actually uses something called MVVM, or model view model architecture. So you'll see folders for that as well. So we'll just minimize them all. So we've got a few things here. So we don't have a main page anymore because I decided to create a menu page. Then the text page is just a stack layout again with that label, the editor, with a, ignore that, that's not actually true, it does exist. But yeah, this uses the app XAML that I mentioned before with an app-wide resource dictionary that you've got here. So we're saying I've specified some colors that I wanted to use across the application. And then I've said that if the component is a button, apply this styling to it. So all of the buttons, whenever I create them, unless I override it by writing it specifically on the component, will use this font family, this font size, this background color, and this text color. So it's nice and easy. Then it just has it uses data binding as well, which if you've not seen before is just kind of creates a link between your view model. So with MVVM, you've got the views for the pages, the models for your data layer kind of stuff, and then the view model acts as a messenger in between, just to allow a bit of separation of concerns and stuff. So a data binding just links stuff from your view page to properties in your view models, because it's not in the code behind and it's now using a view model. You just need a way for it to know where to find the property, and also auto update, because if stuff changes, you want your UI to update. So that's what the binding thing's referring to. And again, even has a command. So command is a bit like clicked, but you use command instead when you're doing MVVM and data binding. Then you've got in the view models, that's where the main crux of stuff happens. So in the analyze text page, we are using backing fields and public getters and setters for the different parts of the page. And then it just is calling, it's just getting those fields. And then when we say, hey, analyze the text, you pass it in that text for analysis, which comes from that text box. Then it goes through and calls a helper class that we created, and then handles the responses depending on what the sentiment is that was returned. It obviously does the zippity doodah, the red sucks to be you. There's also just says you seem normal, or if it doesn't know what's going on, it's in blue. Quickly just look at that helper. So that's just setting up some different bits and bobs. So it uses the text analytics NuGet package from Azure, from Microsoft as part of the Azure AI stuff. So it's really easy. You just set it up with some credentials, because it needs a API key and a URL endpoint, because like with AWS and other cloud providers, you can pick a region where it's deployed. So it just needs to know where to go to look for it. You create the client, and then you set up the document just to send it off. So it's as easy as, a few lines of code just saying, hey, send off the text to analyze it, and then, assign it to this variable, and then get the sentiment back and return it. And then that's what we handled in our switch case. So yeah, fewer than 30 lines of code, and we've already got text analysis in our application, which is pretty snazzy. But obviously the cool stuff is happening with the image page. So the view model, this has a bit more going on. So unlike with stuff like websites, where obviously, the computer's a computer, a browser's a browser, with the different platforms that you can target with Xamarin, the way that you do things that are native phone features will be different to each platform. And, the features are the same, things like a camera, battery, internet connectivity, and all that stuff. but the way that you'd find out on each platform is different. And so to save you the effort, lots of kind and smart people have put together NuGet libraries that you can add in as plugins to your application to give you access to those features. So in this case, we're using a plugin called Media Abstractions, which gives us access to the camera and the gallery. So we just use that library to take the photo, and then we send that photo off to the face client. And then that gives us some stuff to work with later on. So yeah, so take or pick the photo. So we have two options. You're either taking the picture or picking a photo. And once that's done, it then gets the image, converts it to a stream so it can be sent off, and then says, right, find all the faces in that picture. And if there are any faces that you get back, then pass this photo for display over, because as you saw in the results page, you actually got an image of yourself back as well. And then move over to a new page, which is the results page. So yeah, 87 lines of code, and a vast majority of that was just taking the picture. So when it comes to the actual cognitive services side of things and using the SDK, we literally got to analyze the emotion in a photograph and get it back in a matter of maybe a dozen lines of code, which I think is incredible. And it's one of the things I love about cognitive services and why I like to show it off. The image result page is pretty straightforward. It's just actually adding in those items that you saw on the page. So obviously that was a very whistle-stop tour. I just didn't want to I wanted to at least give you an idea of the structure. And then, as I said, there'll be links later on so that you can go through it at your own pace. My Twitter handles on all my slides. If anyone has any questions, by all means, my inbox is open. Drop me a message and we can talk through it. It's also open source, by the way, and it was featured in Microsoft's open source newsletter earlier in the year. So if you think that something is terrible, it is open to pull requests. It doesn't have the Hacktoberfest label, but only because no one submitted a pull request for it. So that can change if it's important to you. So that's the app in a nutshell. But now I want to talk about some more awesome examples, and the fact that the world is your oyster. This is pretty much the epitome of my iPad artwork. I'm quite proud of this picture. Like, it's also a sort of semi-accurate photo of the world, but not quite. But yeah, so there's a few examples that we can talk about. So I'm just going to get the browser back up. And it's all about how, cognitive services isn't just used for fun, silly applications like I did, but also to save lives. So one example is mobile chest X-ray, which is I think it's Xamarin iPad app, I believe. So it was made by some interns back in 2018 at Microsoft Garage, which is their R&D department. And essentially what they did was created this app that allows them to take pictures of a chest X-ray, and then use machine learning to have a look at what might be going on in the photo. So if you imagine somewhere like a developing world country where they maybe don't have access to a load of cardiothoracic specialists who can understand all these pictures, they might just have more general doctors out in the field who are maybe able to take these X-rays but can't do much else. So then that means that all these people that maybe have serious conditions that need to seek medical help urgently, you've already got an app that's saying, well, the likelihood is that you've got something like pleural thickening or a pneumothorax, which I believe is air can't get in your lungs, I think, because that's normally the one where they stab you in the side, I think. I watched too much Casualty, the medical drama. But yeah, essentially it can take away the human aspect and give you access to chest X-ray results pretty quickly. And I just think that's amazing, because if you don't live in a big city, or you don't have access to a consultant to have a look at your results, you could be saving lives by doing this. And continuing the theme of saving lives, another one I love is a skin cancer prediction app. Again, these links are all later on, so don't worry too much. But this blog talks about how they created this application. So it talks you through the more nerdy machine learning side of it and how they train the models. But it ends up with I have to zoom in, and I apologize for the quality, but they essentially ended up with this app. So you can take pictures of, skin lesions or moles or whatever, and then based on all this training that they've done on the models with Core ML, they were able to, actually more accurately predict whether that skin condition is something to be concerned about, which is amazing. Because you imagine if you've got something like a dermatologist, I think that's the right consultant for stuff like this, who's looking at these, they're human beings, mistakes happen, they get tired, they've got to look through loads of these a day. Things will get missed, mistakes will happen, or, they won't be able to get through them as quickly because, they're a human being, whereas a computer can get through them a lot more quickly. So you could be saving lives by spotting these things, because one of the things that's, well known about cancer is that the sooner that you spot it, the higher the chance of survival. So the fact that, you're able to use machine learning and AI and stuff to hopefully get through these things quicker, I just think is absolutely amazing. And, it excites me to see what other things can be done with this. Another great example of AI and machine learning in the real world is an app that's now developed inside of Microsoft called Seeing AI. So I've actually met the guy behind this, which was an honor, but it's a app that can be installed on your phone or whatever, or even a pair of smart glasses to describe the world around you. So it uses things, using that cognitive services to say, oh, this in front of you is a boy looking happy on a skateboard, or, or this, like, there's a road with lots of cars. If you're visually impaired, this describes the world around you to give you independence and keep you safer and just generally more interactive. So I just think the things that you can do with machine learning is just absolutely incredible. So today you've learned about what Xamarin is, how to get started with it. You saw that you can write examples in at least 2 languages, and you've discovered using cloud computing on Azure with cognitive services to do super, super cool stuff, or just pull silly faces. And with that, boom.